So this is part two, where we're going to talk about measures of reliability. In measures of reliability, there are three aspects of reliability I want to highlight. The first one is the test-retest reliability. The second one is inter-rater reliability. And the third one is internal consistency. As I said, reliability refers to consistency, repeatability, reproducibility of a measure of performance. So if you take weight, for example, consistently measuring weight and repeatedly coming up with the same sets of measurements. And an instrument is called reliable to the extent that on repeated use, the scores are not affected by random error. So this is important. If you take a measurement, let's say a PHQ-9, a depression assessment scale, if you repeat it, if you get the same scores, then you would say that the instrument is reliable. What happens if you have a random error? Well, a random error increases score variability, and it also decreases the reliability. So a random error is something that you try to avoid in measurements of reliability. How do we assess reliability? When a new instrument is to be developed or an existing one is applied to a substantially different population, we assess reliability. We want to make sure that the instrument that we are using is reliable. So to provide a context, in the research study that we are leading in the neurogap psychosis, as we speak, we are trying to assess the reliability of the mini instrument as used in the study population. Because this is the first time that mini is used in a new context and a new setting, we want to establish the reliability of this instrument. So reliability study can be conducted oftentimes before the main epidemiologic study. That is the best preferred approach, because it gives you an idea and you can use that information to help refine the main study, or early in the course of the study, because you could use it for two purposes. One, you could use it to evaluate the instrument. That could help inform the results. But it could also improve the instrument and helps to identify interviewers or research personnel who need more training or should be dropped off. So oftentimes when we do studies, we try to make sure that coders or assessors are reliable. So for example, in the study that I mentioned in NeuroGap, we're training clinicians to administer the clinical interview, the SCID. And one of the things that we are trying to do is to make sure before the full study is launched that the clinicians are reliable. And we try to assess this using a measurement of reliability, because we want to make sure that we are getting consistent results. So we assess reliability in three ways. We have other measures of reliability, but these are the most common ones: internal consistency, test-retest reliability, and inter-rater reliability. So the internal consistency is a measure that tells us how well the items are measuring a single instrument coherently. So if all the instrument questionnaires, or if all items included in one particular scale are measuring the same thing, the same construct, they should be correlated to some extent with one another. So they have to be internally consistent. But this is limited, internal consistency is limited by the construct itself. So one caveat is we need to have unidimensionality in order to assess internal consistency. So for example, if you have an instrument that measures multiple dimensions, let's take post-traumatic stress disorder. If we take a perceived a PTSD checklist, for example, which is a self-reported measure or assessment of PTSD, we know that PTSD has different subscales. So if we try to assess internal consistency, we're not necessarily going to have one measurement of internal consistency. We have to take into account the different domains so that we can measure internal consistency within the subscales. So we can report internal consistency by subscales to address this issue. How do we calculate internal consistency? The oftentimes used measure is Cronbach's alpha, where the value ranges between 0 and 1. And a high Cronbach's alpha means a higher degree of internal consistency. However, not seeing a high Cronbach's alpha doesn't necessarily always means a high internal consistency. We have to check for unidimensionality. There may be a situation where we have high Cronbach's alpha, but it doesn't necessarily mean that it is highly reliable instrument. This is just one measure. We have to take into account the unidimensionality of the instrument. Another measure that we have for assessing reliability is a test-retest reliability. As the name implies, it measures how constant scores or ratings remain from one occasion to another. This is something that is administered by interviewers. The same test could be administered over a period of time to a group of individuals. In a study that my colleagues and I led years back, where we tried to look at the validation of the validity of the PHQ-9, we tried to assess PHQ-9 given to a group of subjects 2 times, with the second administration provided in 2 weeks' time. So the same individuals are interviewed twice. That's why we have test, retest. So we're doing the same administration to a group of subjects, but at a different time period, to ensure the ratings, the scores remain the same across the time periods. We don't expect the scores to change in 2 weeks' time because we are assessing a 2-week period depression symptomology. If the test reflects a true or a meaningful, a stable construct, this should be observable in correlation between responses at different times. This is oftentimes limited by the stability of the underlying construct. For example, if you're assessing symptoms about last week using an instrument, and if you try to measure test-retest reliability in a month, you may not necessarily have the best test-retest reliability. So you have to always take into account the stability of the assessment in measuring test-retest reliability. Another measurement of reliability is inter-rater reliability. This is 2 interviewers doing the same interview, for example. So this measures how well do 2 raters or 2 coders agree between each other at the same time. This can be obtained by administering the same test to the same subjects by 2 or more coders. An example with the prior one that we have seen is a PHQ-9 could assess major depressive disorder can be provided to a group of subjects twice, with the second administration provided by different interviewers. So you could have the first interviewer do assess the PHQ-9, maybe a few minutes later, you could do the same thing by the second interviewer and try to see how much they agree with each other. Oftentimes, you don't necessarily have to do interviews. You could have, for example, diagnostic codes or chart reviews, and you could have 2 people review the same chart and see the level of agreement. That would be an example of inter-rater reliability. We would expect scores by different raters to be correlated to the extent that they reflect the same properties of the underlying construct. So we expect the correlation to be quite high. So for both test-retest reliability we have different measures. If we have a categorical outcome, we use what is called the kappa statistics. If we have an ordinal measure, we use a weighted kappa. And if we have a continuous measure, we use the intra-class correlation coefficient. And those are things that would also be covered in your biostatistics lecture. So let's look at kappa. So if we look at kappa, it's assessing test-retest or inter-rater reliability for categorical outcomes, typically a dichotomous or a binary outcome. What it does is it takes into account and evaluates to what extent do two raters observers agree with each other beyond chance. So it takes into account the chance agreement that exists between two raters. This is typically calculated using a coefficient called Cohen's kappa, which was developed in 1960, where we calculated using this formula, where we take the observed proportion agreement and subtract the agreement expected under random chance and divide that by 1 minus the expected proportion. We'll look at this in a simple example. So let's look at this example. We have a rater 1 and rater 2, and we're trying to calculate the observed probability or the observed agreement. So the first question is, what is the observed agreement between the two raters? We can calculate the observed agreement between the two raters by taking the label of agreement 20 and 70 and divide it by the total number. And then we can calculate also the expected agreement by taking the proportional or the marginal distributions and calculating the expected agreement. So we take 20 and 70 divided by 100. That gives us the proportion observed. And the proportion expected would be if we take the number, which is 30 here, and divide it by 100, and we take that, we multiply that by the total number, we would get the individual numbers to calculate the proportion expected. So what we are saying is, if we take those proportion observed and expected and calculate the number, we're able to calculate the kappa coefficient, which is 0.43. In general, we expect kappa to be higher than 0.8 in order to say an excellent agreement. So this is something not that much of a great agreement. There is an interpretation guideline where we take that value and say that this would fall under a moderate agreement. 0.43 would be between 0.41 and 0.46. So kappa could be high simply because the marginal proportions are either very high or very low. So the marginal proportions are those proportions. So the numbers that we have, the marginal proportions could be very high. So the best interpretation of kappa is to compare its values on other similar scales. So is this something that we expect? If you get a kappa of 0.6 and you try to compare it with other instruments that may have similar construct or similar scales. So this is an example of a study led by David Sheehan and his colleagues, the person who created the Mini, where they're looking at the reliability and validity of the Mini interview provided to children and adolescents. As you can see that the kappa values for the inter-rater and the test-retest reliability are indicated in here. And they have quite high levels of agreements. for clinical work, this is something that you would want. This is something that you would expect, because you want your assessment to be quite reliable and something that doesn't necessarily introduce a measurement error.